All right. Hello. Well, good afternoon. Day 2 of Apsara Conference. Before we get started, can I get a raise of hand if those of you who attended the day 1 main event in the morning, where our CEO talked about the roadmap to the ASI, the artificial superintelligence. Can I also get a raise of hand if you attended the day 1 afternoon event, listen to all the product leaders and general managers talking about the product updates? Okay, less number of people. So my role is, think of me as the another AI model, and the AI model is called product manager. And this AI model's function is to ingest and to distill, as well as to summarize all the 5 hours of product updates that were delivered in 5 hours, and then translate and deliver back to you in about 28 minutes. So without further ado, let's crank up the token output rate and get started. Okay, so you all may have heard that, in terms of our global footprint, we're at 29 regions and 91 availability zones. But also by the end of 2027, we're planning to expand into 8 more additional regions, as well as 33 availability zones. And our global data center footprint in terms of data center capacity by end of 2027 will expand 4-fold. So this represents a significant investment, our $53 billion in the next 3 years. At the same time, we're upgrading our network capability as well, interconnecting all these data centers, for example, to increase our internet capacity, bandwidth capacity, as well as especially around, for example, Tokyo, Hong Kong, and Singapore, where these financial centers, customers need ultra low latency through underground cables, or through microwave, or through those hollow core fiber optics. We're able to improve the low latency to as little as 40 microseconds. And in terms of software-wise, we're also proactively probing all these network routings, and then able to basically switch with a sub-second level and improving the overall network connectivity and robustness and significantly. And this is what we call the route technology. And the route technology really started initially maybe about 2 years ago, when we were connecting between regions to region, and then AZ availability zone to availability zones. And this year we're really deploying across connectivity between services. So all these network will enable us to have a global, one central network enabled to host all your services. At the same time, you may ask, what is our product? How is our product differentiated? What are the challenges, or what are the benefits of Alibaba Cloud technology? So Alibaba Cloud really start from the hardware, and this is our little graph down below is our CIPU 2.0. And we say it's CIPU 2.0 just to make sure we confuse people. It's really our 5th generation of hardware. And this is developed as a CIPU stands for Cloud Infrastructure Processor Unit. And its purpose is to hypervisor offload, as well as provide I/O and storage acceleration. Today, it also provides encryption offload so that you can have encrypted VPC without any performance degradation. And on top of that is our self-developed, across 15 years of storage, compute, and networking software stack. And they said, hardware eventually fails, software eventually works, and it took us 15 years to really make this work perfectly in Symphony. And the other thing I would like to emphasize is that all of our infrastructure layer product advantages are fully exported by our PaaS layer, or our upper layer, and so that the complete technology advantages are fully explored all across the entire stack, and working together end-to-end solution to provide the best value as well as the best performance to our customers. So let's go through some of the scenarios. We talked about AI innovation. Of course, we talked about the roadmap to ASI, the superintelligence. But fundamentally at core, what is enable ASI is our Lingering AI supercomputing cluster, which is able to connect 10,000 GPUs together in a single cluster, 100,000 GPUs in a single cluster. And also, but you say, hey, everybody does that too. You can hear from other hyperscalers. So what is really differentiated about our Lingering? So I will propose to you 3 points. One is, when we designed this infrastructure, we really designed for multi-tenancy. It's different than just renting out a set of hardware for a month at a time. It's not monthly hardware rental. This is provided to our customers as infrastructure, as a service. You can turn on the link service in as little as a few minutes. And it's able to host all the different, our customers' training workloads, because we do host about more than 50% of innovations around model training in China. The second differentiator is that as we're moving more towards a mixture of experts, sort of architecture, it is also optimized for not only training but also inferencing. And more of our customers using the same set of sort of hardware and architecture to be able to run both training and inferencing. And maybe you're running inference during the day and you're running training during the evening. So this product is optimized for both inferencing and training. And third is, if you think about the difficulty with creating a huge AI supercomputing cluster, one of the statistics I would offer you, you may not have heard it before, is that GPU failure rate, according to our statistics, fails about 500 times more than CPU. That's not 500%, that's 500 times. So why is that? Because you're using all your GPU to the extreme, and then GPU itself could fail. And if you're running a single cluster of thousands of GPUs, any of the GPU failures will then stop your job. So how do you ensure to have your infrastructure run smoothly with all this incredible high failure rate and still maintain the coherency of locality of all your compute? So this is the challenge that our product faces, and we would proactively be able to detect 98% of different type of failures and dynamically provision different reliable resources, and yet keep computing close cluster together, enable your customers to run your effectively training up to 99% of your training time. And this 99%, really, this is at the top end of the world leading in terms of what we'll be able to accomplish. It's sort of like, if you think of launching rocket into space is hard enough, but this is actually equivalent to be able to also retrieving the rocket back to your base. And this is our state-of-art technology of our Lingering cluster. But then that's not all the Lingering cluster, and most of our computes are provisioned through containers. And the way we're thinking about containers is not just about the orchestration and the management layer, but also we're thinking of computing as container native computing. So the computing resources provided to container natively and optimized for container. So you can provision a pod via the YAML file as little as 0.5 core and 1 gig of memory, and then expand your pod dynamically vertically into 5 core or 5.3 core or 5, whatever in memory as you need it. And you can scale out seamlessly as well based on, for example, CPU utilization rate or time of the day. So this is really a scale out and scale out completely flexible, composable infrastructure. And not only that, we're introducing the ability to basically hibernate your pod. And you may say, why do you want to hibernate those compute pods? Easy. For example, if you're running agent inside a pod and your customer goes away for 3 hours or go to sleep for a day, then they come back. So you don't want to go through all that computation again. You want to be able to reawake the pod and go back where you pick up where you started. Where you left off, rather. And this ACS product we GA'd officially last year during this conference, and today, on a daily basis, we are already able to, statistically speaking, basically spinning up 10 million pods in the production environment by our customer. And the other number that noticed here is the elasticity to be able to spin up 15,000 pods per minute. And this is not just a marketing number. It's actually, when we go to POC with our competitions, we can actually prove it to our customer, and our competitors can only deliver half as much in terms of number of pods able to spin up in a single minute. So this is our compute sort of update for AI. But now let's talk about storage. So in this age of AI, storage requirement is different. We require a very large file system that can host billions of files, and then to be able to feed all those GPUs simultaneously. And this year, our lead with product is Cloud Parallel File System. But this year, we're actually introducing essentially a same namespace, but data placed across 3 tiers of storage. You could have the highest performance tier close to your GPU in the local SSD, and then have a distributed cache layer to basically it's a recache closest to the GPU. And also when you have those inferencing, you basically have a disaggregation of prefill and decoding, and then you connect it with KV cache. If your KV cache overflows your video memory, you can offload to this cache layer as well. And then our high-performance file tier, we expanded this year to 20 petabytes. So 20 petabytes of all-flash high-performance file where data is completely evenly distributed across all the nodes, all the storage nodes. The file metadata is completely distributed, and even the file handles are completely distributed. All this to enable parallel file system access. And then a lot of our customers, their data grows over time, right, into hundreds of petabytes. And when you do that, your hot data doesn't have to be, maybe it's only 20% of your data is hot. So you wanted to basically move that data seamlessly to object storage, yet maintain the same file namespace and seamlessly recall from object storage as needed. This is a way to reduce your overall cost and still improve your performance. But then this year, we're also introducing, very excited to tell you about, first time ever, we have introduced a new type of bucket. It's called a vector bucket. And the reason we are doing this is because if you look at our object storage today, there are trillions of object storage on object storage, and most of the customers in a single bucket can contain over 1 billion objects. But how do you, and those objects are all usually, unstructured data. How do you search for the right data, right? If you're like me, I can't even search for the right PowerPoint. So how do you search for all the content? You have to be able to understand, and the way to search for the content is by vector. But if you were to vectorize all your unstructured data, you realize your vector data will be as big as your original data, sometimes even bigger. So we need a way to to store these data at a low cost, and yet provide sort of a low-cost query capability as well. Of course, you can store your vector data in database, which is most people do today for higher performance, but this is a way to basically vectorize massive amount of object storage or unstructured data and containing object storage. And also in object storage, today is people using object storage as the base for data lake. Running big data analytics engines on top of the data lake all the time. And so all of a sudden, your object storage not only houses your big data applications, but also houses your AI workloads. So you want it to be able to distribute amount of performance from your single bucket, essentially your throughput out of the bucket to the right workload. Sometimes you want your AI workload to run faster, so you may allocate more bandwidth to AI workload. If you want your big data jobs to run faster, you can adjust it dynamically. And this is how we're talking about the bucket quality of service bandwidth allocation. And also, what we're doing is, if you think about object storage, it is regional service, right? You don't know which AZ it is in. But we're introducing the OSS accelerator that's AZ aware, because you know where your GPU are and all your computes are. So you can accelerate from a regional service to AZ specific or availability zone specific services, and to provide strong consistency data. You don't have to compromise on the data itself and service your GPUs or CPUs. We're also, so now that we have buckets, now that we have vectors, we're also upgrading our object storage into content aware. And I'm very excited about this because this is going to be the industry standard for storage going forward for the next, I would say, 10 years, where we're turning object storage not only as a place for data placement and object storage, but also turning into a knowledge base, where you can basically self-discover the content that you have, and you can use an agent basically call and retrieve the content. You don't have to know about what your data, which files has what data. And also, anytime when you have a new data, you can say, for example, anytime when somebody's uploading a picture or a video of someone kicking a soccer ball, please notify me. So we could do that as well. So any incremental data gets uploaded to object storage, we will automatically discover its content and alert you as well. So then let's talk about networking. And there's three sort of upgrades on the networking that's associated with AI. One is ALB, which is application load balancing. This is our sort of layer 7 load balancing, historically looking at the TCP/IP header and be able to balance across the different applications. But also we're now doing this for token as well. So you can, when you're having inferencing, you can also do load balancing across basically your different models. And then because your compute is sort of located in different geographies, oftentimes you need to basically transfer a huge amount of data across a vast amount of network. And then GA, or global acceleration, is very good networking capability that allows you to accelerate your data transfer across network globally. So two upgrades to the GA is or global accelerations. One is the built-in WAF capability. So basically, it has its native firewall protection, and also the Anycast capability. Basically, in a whole entire world, you can have one IP address, and it will decide where your close proximity in terms of access automatically to have the close proximity routing as well. So then you have besides the storage, compute, and networking, and on top of it is, of course, our container orchestration. One important thing about container orchestration, you want to manage all your resources, right? You want to manage all your lingering resources or ECS resources located in different parts of the world. You want to have a view of where all your resources are, and to be able to orchestrate and to manage your task, assigning which tasks running on which resources. And if you're running inferences, you have maybe some of the pods that are doing prefill, some of the pods are doing decoding, and our inference gateway is KV cache aware. You will route to the right, basically, set of worker groups as needed. And so it's centralized, basically, management enable you have a single pane of glass to orchestrate your containers. And then on top of containers are our Pi, which is platform for AI. And very excited about we're introducing Pi Prime, and under Pi Prime, we're introducing 4 basically training frameworks, and it's optimized for each of the frameworks in terms of MOE training, reinforced learning, or Fuse. And then these, if you're using Prime and using these training frameworks, you'll see your training time up to 3x speed up. And our Quinn models are all trained on Pi, and so this is a testimony of our capabilities. And all these Pi capabilities are encapsulates all of the underlying storage compute network capabilities as well. And then in terms of inferencing, with the Pi EAS, it's a cost effectively for inferencing nowadays with billions or hundreds of billions of parameters. Inferencing becomes a challenge as well. You wanted to have a high-performance network to host all the different compute capabilities, and then link them together. And then perhaps you want to optimize your inference to have lower time to first token, or you want to have your inference to optimize to have a lower time per output token, or you can optimize the throughput. But the key is that in order to go through this very complicated ML ops, you can just use Pi EAS and adjust this dynamically. You can either, given a set of finite resources, you can either optimize for performance or optimize for throughput or customer experience. So all that can be adjusted dynamically to suit your needs. And then you need to have end-to-end. To really productionize your AI, you need to have end-to-end monitoring. This is all the way from application down. You want to be able to understand how much resources are being consumed per each user or per each token. You want to understand if you do have a slowdown, right? We say slowdown is the new, slow is the new downtime, right? You wanted to optimize proactively your performance, and you wanted to be able to make sure that your data is moving in a secure fashion. So all this end-to-end monitoring, a single pane of glass, will enable you to manage your operation across AI. So in conclusion, on the AI aspect of it, we have updated the whole portfolio with all these functionalities, and they're working together in cohesion to provide a complete AI platform for your AI innovation and workload. But it's not just about coming up with new applications. It's also about connecting AI to your existing environment, to train your AI based on your existing data and to optimizing your existing workload and to achieve higher efficiency. In terms of database, we have encapsulated all the AI capabilities in the database through SQL, SQL query, or API, so you'll be able to process your AI in the database. Also, at the same time, all of our database, the majority of databases such as PoloDB, ADB, and Lindong have upgraded to serverless architecture to not only be able to spin up CPU resources as well as GPU resources in a serverless fashion, increase the performance and efficiency. Also, at the same time, all the databases work with object storage as well, so deliver multi-model type of analytics as well as search, and reducing the overall cost by offloading some of the data to object storage. So then, if you're building a RAG, so a lot of people are building an enterprise RAG. What do you need an enterprise RAG? You need an enterprise RAG you build with vector database, but also you'll notice typically a RAG will only be good for a certain domain and searches within the domain. You'll need a graph, knowledge graph to basically connect the RAGs to have this semantic aware search. And building these complicated knowledge graph is very costly and it's a daunting challenge. So, but we enable that with our database to connect with our the AGE, basically our Postgres plugin for graph database with all of our databases, and our databases also natively has the capability of vector database capability as well. So putting this together, you will be able to basically have a higher position on your RAG with graph RAG, and also reduce costs as well. And so even though you have a number of choices on your database, depends on your workload, you optimize for different type of database, but you need only one platform to manage them all. And this platform is DMS, to manage all the metadata, to manage all the data governance in the database, and also have unified data ops and agent. And also you need only one platform to basically process the data from your enterprise data to make them AI ready. And that's our DTS one channel to be able to embed, to do vector embedding, and to basically feed those into the databases and make them available for AI applications. And then to our big data architecture, last year at Apsara Conference, we announced our open lake solution architecture. Basically, it's able to ingest all these different formats of data, whether it's PEMA, Iceberg, Lens, or the more of a traditional OCR or POCUE, those type of data format, into one data lake, and then you're able to run your batch processing or your stream analytics, all that with different type of analytics engine. And then you manage essentially all your data development using DataWorks. So Max Compute does just that, and this is our lead with offering on batch processing. But not only Max Compute does all the batch processing, now it's also able to offer nearline query, near real-time processing as well as incremental processing. So incremental computing. So Max Compute also incorporate all these AI functions and capabilities which you can invoke via SQL. So it becomes not just for a big data engine, but also AI engine as well. In terms of Holograph is our real-time analytics engine, which delivered really low latency, fast real-time response on these analytics, and it's also upgraded with AI capabilities and AI function operators to simplify AI development inside of this big data engine. It also works with object storage to be able to essentially consume the object tables, and so it's not only for structured data, but also semi and unstructured data analysis as well. And then, as Alibaba years ago acquired Viverica, which is basically the funder of Flink. We're also upgrading Flink with another community-sponsored Flus, which is basically, if you look at stream analytics, it never really had a storage. And Flus is basically storage for stream analytics. You can contain storage maybe in 7 days and rotate it around, but in that 7 days you can update those data and you can have those column-based storage and speed up the query, as well as all these updates will have change logs. So in one place, you don't need an ETL, and it's more efficient than perhaps the open source Kafka. And we also, in terms of our or big data analytics engines, host all these open source analytics engines. But we have our own version, enterprise version of these open source engines, such as EMR Spark and Starrocks. And our differentiation is that even though they're the same as the open source, but we improve the performance by 2x. And so that's a very substantial benefit to compare to if you were building your own. So when we think about data development in the age of big data, right? You have all your data assets that you manage, and then you feed into different analytics. But today, the same set of data also feed your AI machines. And if you were taking all your enterprise data and you were to come up with a really, really, really good model, you want to be able to go back and say, okay, which data did I use to train this model on? And you want to be able to centrally just not only develop your do data development for your big data applications, but also for your AI applications. And DataWorks enable you to do all of that with basically the IDE environment and the notebook environment. And then let's switch finally to another gear in terms of high availability and enterprise applications. At the end of the day, that's our bread and butter. I hate to say it, some people view it as traditional, but this is still very important to our enterprise. So our posture on that one is that we want to deliver value to our customer where it matters. Not all applications require highest performance. So we have upgraded our instance, basically our universal instance. These type of instance, you don't know, we abstracted the CPU, so you don't have to worry about which generation CPU that you're on. You can take all your tier 2 applications, office applications, load onto a truck and dump it all on this U instance. And it will just run flawlessly with very cost-effectively measures. And our U2 instance with both U2i for Intel and U2a for AMD, basically they were up compared to U1 instance. All the performance the baseline performance to see a dramatic increase up to 40%. But also on top of the baseline performance, it's able to burst the compute performance, the storage, and network performance about another 20%. And the cost of TCO of that is also reduced dramatically. So this is, for all your back of office applications, this is the best platform to run those type of workloads. And then for enterprise applications or databases, we recommend our Intel-based offering based on 9th generation ECS, based on the latest offering from Intel. We see a 20% performance improvement, and also we reduce the list price by 5%. So you truly get a better price performance across all. And then we upgraded our AMD instance as well for first time ever, also first time ever in Alibaba Cloud, but also in our the Chinese hyperscalers. We're introducing a physical core type of instance with hyperthread turned off. So you may ask, why did you do that? Because we noticed a lot of the customers will get benefit when they're running big data on AMD. And those big data workloads are memory intensive. By turning these physical core off, you will reduce the noisy neighbor problem, and also you will make sure the memory bandwidth consumptions are equally distributed. So when those numbers are not just spec numbers, they're real life scenarios. So the real customers are seeing a 43% increase on big data workload just from one generation of AMD instance. And then our PoloDB also have a innovative approach as well. So we talk about storage and compute disaggregation, separating the storage from compute so you can scale independently. But also with PoloDB, you can scale out memory as well independently with the CXL technology that you can use remote memory as if it's local memory, and you can expand all three type of resources dynamically as needed. And this type of basically hardware architecture and the product architecture enable you to run the highest performance possible and setting the world record for TPCC. And also PoloDB, you are used to databases just one single writer but multiple reader, but now you can have multiple reader and multiple writer. So performance is very important, but it's not everything. reliability especially for data, availability and reliability is important. You want to be able to have your data to be protected against zone failures. And when we do have a zone failure, you want your data to be distributed, have RPO and RTO equal to 0. And we have availability of our object storage in basically 3 availability zones, but also in 2 availability zones. EBS, if you choose a regional EBS, without changing any applications, all your data will be distributed across 3 availability zones. And because this is such an important technology, the PaaS layer in terms of databases, in terms of backup, all incorporates this type of capability. And all the snapshots are zone redundant. So if you take in the snapshot of your block storage, and if a zone goes down, then you can recover in another zone. And the same with our database, to make sure that databases are also locally redundant, regional redundant, and across global with active capability. And of course, with our big data analytics engine as well, with Max Compute. And then let's talk about security. So security is very interesting in the age of AI. One is security itself is evolving with not just rule-based security, but also AI-enabled security. About 80% of our security today are still rule-based, but 20% are now enabled by AI. In this working in combination, we'll be able to provide the best security to our customers. And we are also using security for ID identification, to provide facial recognition and deepfake as well. So a lot of the AI generation will generate facials or videos of someone that's not real, and we are able to basically use this deepfake detection to understand if you're real or AI generated. And as more and more customers running workloads, we basically use AI Security Center to take a full inventory of what are the AI assets that you have, what are the models that you have, and what models, and be able to scan all these models to see what are the backdoors on these models. And if you're using a polluted model and then you train another or fine-tune another model on top of your enterprise data, and the model that you came up with is also have those same backdoors and security vulnerabilities. So with our security center, we will scan full inventory of your AI assets and to provide you a comprehensive view of your security posture. And in terms of inferencing, so you could inferencing things that are not, you could generate malicious code in terms of the AI model, and your output could be problematic in terms of content that may not be, it may not be, or it could be violent, or it could be whatever. It may not be kosher. So all this AI capability with AI guardrail that we announced this year is able to basically govern, and I guess across the door as well, talking about responsible AI to manage these inferences as well. So finally, it's not about just running your enterprise workload. It's not just about running AI, but it's also using AI in our Alibaba Cloud products to make our product usage so super simple. So when we're talking about using AI historically, right? If your SREs or your maintenance team, they would have to sort of understand what data is producing. They will have to process the data and figure out what the problem is, and then come up with sort of a task to figure out what to do. With Copilot, basically we're enabling our SREs or maintenance team to be able to ask the system in a natural language form. Then we will try to attempt to understand the data and provide basically the data to the maintenance SRE. But in the age of agent, basically your SREs will just need to set objectives, and your agent will execute those objectives automatically. So it's more and more agent or AI is able to take those responsibilities and less involved with human. And we're doing that with AI agents across all the products, such as object storage, ECS, and network. But more importantly, you need an agent to basically run across all these products to have a comprehensive AI operation. So, and also in terms of databases, we have agents that manage across all your databases, as well as if you were to using an agent to basically process your data. You can set your goals, and it will understand in terms of natural language what you try to do, and it will check all the required information. You set the plan, and then you will execute the plan and generate the output. So, in conclusion, all these products updates basically summarized into 3 key points. One is our technology leadership across the stack, integrated horizontally and vertically. We are investing heavily across the world with our current largest scale in AP, but geo expansions in parts of Europe, in North America, South America, and Middle East as well. At the end of the day, we want to provide cost-effective, comprehensive solution to our customer, able to accelerate your AI innovation, to be able to revolutionize your data intelligence, and facilitate your enterprise workload. Thank you.